A company is currently deploying web applications to EC2 instances behind an application load balancer via an automated yet unreliable process that uses Lambda to trigger CodeBuild and Systems Manager run command. This setup has resulted in deployment failures and configuration drift across instances. Which two actions should a DevOps engineer take to transition to a more reliable, standard deployment architecture?
The options are: Option A, configure AWS code pipeline with code commit as the source, set up parallel stages for build and test, and pass the resulting artifacts to an AWS code deploy deployment provider. Option B, build an AWS code pipeline workflow using code commit as the source, define sequential stages to build and test the code, then pass the final artifacts to an AWS code deploy deployment stage.
Option C, implement an AWS code deploy application and deployment group to handle application delivery to the EC2 instances, ensuring the target deployment group is configured with the existing ALB. Option D, replace the current Lambda-based deployment logic with dedicated Lambda functions that execute code deploy operations for building, testing, and deploying. Option E, use an Amazon S3 bucket as the artifact store instead of code artifact, and configure AWS code deploy to perform the delivery.
This question explores the transition from ad hoc, script-based deployment automation to managed CI/CD orchestration. The core problem is reliability and drift, which often occurs when deployment logic is custom-coded rather than using native services designed to manage the lifecycle of application delivery. When evaluating your options, consider how to best separate source management, build orchestration, and deployment execution to ensure consistency.
I believe the correct answers are Option B and Option C. To achieve a reliable and consistent deployment process, the company needs to move from a manual trigger-based workflow to an orchestrated CI/CD pipeline. Option B provides this by using code pipeline to manage the flow from source to build and test. It ensures these steps occur sequentially, which is crucial because you must successfully build your code before validating it.
Option C is correct because it addresses deployment reliability directly. By using AWS Code Deploy with a deployment group integrated with an existing application load balancer, the engineer gains built-in features like health checks, rolling updates, and automatic rollbacks. These features are specifically designed to eliminate deployment inconsistencies and instance configuration drift.
Regarding the other options, Option A is incorrect because build and test stages should typically follow a sequential order, not parallel, to ensure the code is stable. Option D is less effective because using Lambda for orchestration adds unnecessary complexity when native services like code pipeline exist. Finally, Option E is incorrect because changing the artifact storage location does not solve the underlying issue of unreliable deployment execution.